Morning, everyone. I trust that everybody is fully caffeinated and ready to go. It's going to be a good day. Today I wanted to talk to you a bit about our journey at Anywhere Real Estate with MongoDB Atlas, and specifically how we ended up adopting MongoDB Atlas Search. Oops, there we go. So I'm the Vice President Chief Engineer at Anywhere, and Anywhere is one of the biggest companies that you may not have heard of. Our brands include Better Homes and Gardens, Corcoran, Coldwell Banker, Century 21, ERA, and Sotheby's Real Estate. So a lot of brands that you've probably heard of. So I wanted to take a slightly different approach to what I'm doing today, and I wanted to start with sort of the end state of what we were trying to do with our centralized search capability. So if you look at what's on the screen, this is a representation of a typical real estate search website. Could be a mobile app or whatever, but you'll see that it's fairly representative of what you see from many of our competitors as well as our own websites. So it's important to look at this because it's really quite complicated what has to go on this website. So number one, there needs to be an entry point, and that entry point needs to support different types of search. It could be a city, it could be a city-state combo, it could be a zip code, it could be a neighborhood. It also needs to have simple filtering, what type of, what square footage range, number of bedrooms and bathrooms, price range. It needs to have advanced filtering, right? You can have things like number of days on the market, other different attributes that you might want to use to filter the result set and get a smaller result. Once you get the result set, you need to be able to view the properties and then click on each individual property to look at the details. Now, it's important to note that there's a lot of data associated with each one of these properties, right? And images. So there's a significant amount of processing that's going on, and there's an expectation of extremely fast performance. You also need to have geo-searching, right? So you can draw a custom geo-shape and only see the properties inside of that geo-shape. You need to represent the geo-shape on the website. And lastly, you need to have individual geolocated pins for the properties that match your search. So there's a lot going on here, and I think when I last looked, there are about 2.1 million active listings right now in the United States. So there's a significant amount of data. So when we set out to build our new search capability, we had some business goals and engineering goals that we wanted to achieve. So I wanted to walk through those real quickly. So first is we needed a modern tech stack, right? We wanted to recruit good engineers. We wanted them to be excited about working on this tech stack. We also had functional benefits that we wanted to get out of that modern tech stack. I mentioned fast response earlier. It's extremely important, not only for user experience, but also for SEO rankings. And SEO rankings are what determine where you land in a search engine. Flexible, needed to adapt as the business evolved. Scalable, needed to grow with the business. Low operating cost. I'm going to harp on this one many times during this presentation because this is the key to all modern systems. Automate everything, make it cloud native, make it simple to use. Don't have complexity for the sake of complexity. Proactive maintenance. I don't want to deal with maintenance windows. I don't want to deal with emergency patches. I want it to be patched automatically. And then another thing that I'm pretty passionate about is proactive issue resolution. You need to have observability and monitoring in a way that allows you to identify your issues and potentially resolve those issues before customers even realize they're there. So those were our goals. So how did we end up choosing MongoDB Atlas? And I'm going to go back a little bit in time and not talk yet about search, but just Atlas in general. So we started actually with a couple of different use cases. We had some APIs that we were building, and we also had a transactional system that was used for real estate marketing and advertising. And when we went to make the decision to use Atlas, we had some developers that already had experience with Atlas, right? And sorry, I got myself out of order there, backing up. And those developers had actually used Atlas in other locations, right? I had used MongoDB, but not with Atlas. When we first started using Atlas for a transactional system, it was a little bit of a surprise. I was kind of skeptical at first, but I was quickly converted. Schemaless, I mean, using MongoDB, the schemaless thing is pretty powerful. If you haven't explored this feature, you should. An example, again, back to that marketing and advertising system, we have multiple different order types that are all stored in a single orders collection. Each order type has a very different schema, but yet they're all orders. And you don't end up with some superset of fields that hold no value for a order type that doesn't have, that it doesn't apply to. So it's really nice to have a schemaless system. Low operational overhead, told you I was going to harp on that one. It just works. Developers can bootstrap a new cluster in a couple of minutes. It is really easy to use. It's perfect for cross-functional teams. So we made some decisions around what tech stack we were going to use for a lot of our new stuff. And we chose to stick with JavaScript, TypeScript, JSON, BSON, front to back. So front end, back end, data layer, and automation, all built using the same tech. That means my engineers can pick up tickets based on the next highest priority. Doesn't matter what kind of work it is, they can all do it. Security is built into Atlas. You don't even have to think about it. The defaults work. There are configurable options to make it better, but it's there. It scales. You can configure auto scaling when you set your cluster up. It's seamless, right? You don't even have to think about it. It'll scale up and actually scale back down as needed. High availability, again, when you configure your cluster, you can set multi-AZ, multi-region, sharding, numerous different options that allow you to ensure that that particular cluster will not be impacted by a localized incident. Backup and restore functionality, again, another case where Atlas just gets the defaults right. You really don't have to touch it unless you really want to. Monitoring and alerting. This is an interesting one, right? Because I don't think a lot of Atlas users know that the activity feed exists at the project level. So it's kind of hidden. You have to go up to the project level and find the activity feed. But it has every single thing that happens to that cluster, both from users as well as systemically, right? So you can look at everything that's happening, you can troubleshoot issues, you can figure out what may be causing your slowdown. It's all there in the activity feed. And you can build alerts on it too. Patching and upgrades. I mentioned this earlier, automatic minor version upgrades, it just happens. You can select a maintenance window if you want to. If you don't, it'll just pick one for you. Multi-cloud, pick your favorite cloud provider. We're an AWS shop for the most part, so we use AWS, but I know of other places where they're using Azure and GCP. Troubleshooting, performance tuning. This one is something I do every day. The Atlas console is great. The number of metrics you can see about the individual nodes in the cluster, what's happening with caching, you name it, it's there. You can also look at your queries. I use the query profiler on a regular basis. I look at long-running queries, and I also look at examine versus return ratio to determine where I might want to spend some time performance tuning. And then lastly, the performance advisor does provide insights for index changes, and I would say the performance advisor has value and it has improved over time, but beware of its advice because it will sometimes tell you to do things that you might not want to do. So be careful and make sure you evaluate what it tells you to do. Plenty of integrations, custom webhooks we use, Slack teams, Datadog, we use all of that. Online archiving. This is an incredible feature. Your older and infrequently used data can be stored on lower cost storage. And change streams. We use change streams a lot. The primary use case for change streams, for us anyway, is for audit trails. Instead of having to build complicated audit trail logic, I can use change streams to write those audit records into a separate collection, and I have a full audit trail. So that's how we chose Atlas, right? All of that stuff was considered in our early days, and that's what got us to a place where we really, really like using Atlas. So how did we bring Atlas Search into the mix? Apologies, I messed up my slide there. That wasn't supposed to appear until later, but we'll ignore that for now. So we actually looked at several different search solutions, and we ended up with two finalists, AWS OpenSearch and MongoDB Atlas. And what we did was, we decided that we wanted to do sort of a comparison of these two, a fairly detailed comparison to figure out which one should be the one we should use. And we wanted to compare on several criteria. How did it perform? Is it scalable? Does it support our autocomplete requirements? Because we had some pretty specific autocomplete requirements. The infrastructure build and maintenance stuff that I talked about earlier, we wanted to evaluate that. The operational overhead of keeping it synced and the regular updates to indexes that have to happen because we have feed data coming into our index all the time as properties and listings are updated. Is it flexible? Will it grow with us and allow us to make changes? And so the result, getting straight to the point here, is we selected Atlas Search, right? And this first point is really telling because when we ran these 3 different performance test scenarios, each with 100 virtual users against, and we're using K6 as our load generator. You can see that MongoDB Atlas Search beat OpenSearch in every single use case by, in most cases, 3x, sometimes 4x. Now, I will point out that we probably could have spent a lot of time tuning OpenSearch to get it to perform that well, but we didn't need to because Atlas Search was already performing that well. So we just said, why spend that time if Atlas Search already performs that well? Back to the easier to build, this is incredible. If you're not using dedicated search nodes, and I will hit on that later, to create Atlas Search, you don't have to provision infrastructure, you don't have to do anything. You just create the index and it automatically starts the processes, it automatically builds the index, and a few minutes later you have a functional Atlas Search index. It's easier to maintain, it's easier to develop against. I really like this feature because your search queries are just another stage in your MongoDB query pipeline. So you can start with the search stage and then you can pass it to other stages. So mixed queries are possible. It is important to remember though that the results coming out of your search stage need to be small because they have to be transferred between MongoD and MongoT. So those two different processes. It's easier to operate because the entire concept of syncing data from my primary source to the search, you don't have to deal with it. It just automatically happens. So when we went to actually implement this in production, what were the challenges we had? What were the things we learned? So let's talk about that for a minute because it was an interesting time. So number one is deployment. Like I mentioned before, Atlas makes it super easy, and we saw this over and over again that we were able to create environments, tear them down, transfer data, provision new indexes, test the indexes, test different configuration for the indexes, and it was all minutes to make the change. Performance testing. So this one is interesting because during the process of implementation, after we had selected Atlas Search, we still were constantly running performance tests. And if you've got any experience with performance testing, you know that it's always very difficult to create your model. How do you get a performance test that is representing reality of what will happen when you put it in production? And I don't think you ever do, to be honest, but you try to get something that is as close as possible so it's directionally correct. So we spent a lot of time adjusting our performance tests and getting to a place where we had a fairly good idea of how things were performing. And we knew, based on that, what we wanted our anticipated query performance targets to be. And we kept trying to adjust and achieve those targets. And it took us about a year to get there. Now, the reason why it took us a year to get there is because we were early adopters and our use case was complex and we ran into some challenges, to be honest. But this is a good story because MongoDB was an incredible partner through these challenges and they helped us solve them sometimes quickly. Sometimes it took a little bit longer, but they understood the problem and they helped us come out of the other side with a viable solution. So we had challenges with sort. Because if you think about real estate, you always want to see the latest updates, the price changes, the new listings. You want those things to be at the top. And that can be a problem when it doesn't perform well. Search suggestions. We have complex requirements around how we suggest search criteria to users. And in doing so, we ultimately landed on a 3-query solution. So we had to actually run 3 different search queries. Well, that was taking a lot of time and the performance wasn't good. So we ended up landing on a solution where we union the 3 search queries together. And there's a flag with search called concurrent, so concurrent true, and that will spin up a separate process for each of the unions. And in doing so, we were able to reduce the response time of those queries from, I think it started around 2 seconds, and then when we first implemented the union query, we were down to around 700 milliseconds, and then when we use concurrent, we're now down to, and I'm going to steal my own thunder here because I'm going to tell you some metrics I'm going to talk about more later, but we're now in the 170 to 200 millisecond range with that union query. And then keyword search. We had to create a custom text analyzer within Atlas Search because all of the default analyzers did not work the way our business requirements were defined. Next bullet, professional services, right? We used professional services. We wanted to get it right the first time, and they helped us solve all of those challenges I just mentioned. They helped us with cluster sizing. They helped us with query optimization. They helped us with performance testing and continually evolving our performance test approach. So it was a very valuable engagement, and I'm not sure we would be where we are without that professional services engagement. But we don't use it for everything, but we did use it for this. The other thing that I wanted to call out was during this process of getting this feature rolled out, we did run into some things where Mongo just didn't work the way we needed it to. And this is a great story because, again, MongoDB was a great partner and they helped us find solutions. They accelerated some new features. They let us be beta users. We brought those features into our product, and we ultimately now have capabilities that do what we need them to do around sort and pagination, which were 2 of the big things that we had to be early adopters for. Engineering observations and outcomes. It's been stable. We haven't had any incidents. Operational overhead. It's simple to maintain. I won't go through the bullets because I already have. Performance. Our initial query response targets were 200 milliseconds. We actually are seeing, and let me explain these numbers a little bit. So this is our Golang wrapper API that we measure the performance of because we don't measure the performance of every single query. And so you have the overhead of Golang, you have the overhead of the network data transfer. So you see P75 results are 170 milliseconds, P95 are 350 milliseconds. Assume Golang and the network is 45 to 50% of that. We're probably under our 200 millisecond target. Challenges that we're still working with, we have those periodic real-time or near real-time data updates. They slow the system down as the indexes are rebuilt. And that happens every 15 minutes right now. So we're working through some solutions to help solve that. And again, descending sort by last update date and pagination, there's challenges there getting it to work the way we want it to work, and we're still working through those. What's next? Dedicated search nodes. We're already using dedicated search nodes in a couple of our smaller clusters, and we're about to roll them out on the search cluster. This is important because dedicated search nodes give you horizontal and vertical scalability. Potentially reduces your resource usage on the primary replica set, and I will say it does do that in every case that we've seen thus far. Improved search performance. This one is interesting because we've seen improved search performance in some cases, but not all. And we're working through what that means. Do I need more search nodes? Do I need bigger search nodes? Do I need to tune my queries? We're not quite sure why we see performance in some areas, but not in others. We do see improved query performance on the primary replica set. So moving the search process off frees up resources, so the regular queries run a lot faster. Data loads run faster, and we also see that the Atlas console loads faster. The metrics pull up quicker, switching tabs is faster. Again, less resources being used on the primary replica set where it runs. And the other thing that we're doing, Vector DB. We have done a couple of proofs of concept with Vector, and we're in the process of trying to use vector to do some pretty cool stuff around more accurate search, enhanced property suggestions, and natural language search. It gives you the same benefits as Atlas Search because it's the same deployment model. You don't have to think about vector, it's just there. The data is stored right next to your primary data. I'm skipping through the bullets pretty quickly. And there's no sync tax to have a separate vector database. And that's it. I mean, that's where we are. That's what we've done, and it's been a fun journey. We've got a lot more to do. And with that, I think I'm pretty close to time. Thank you.
It's for Brian. Any questions for Brian? Okay. Oh, here. So you're going to question it here.
Sure.
All right.
Thank you, Brian, for walking us through. So I have a few questions for you. So in the first couple of slides, you were explaining about schema-less, thing which made you choose Atlas and MongoDB, right? So at anywhere, you may have the websites loading in different devices, mobile and desktop. So when you are fetching the data across different devices, you may have situations where you want to not overfetch the data between mobile and desktop. So sometimes in desktop you may need all the data points, whereas in mobile you may not need all the data points, right? So we have also encountered such situations, and we have tackled it through graphical, where schema was like, schema plays a critical part to construct the graph, right? So I'm just curious to understand, how are you tackling this situation at Anywhere?
Sure. So basically we're doing a couple of different things. One is that we're using projections, right? So we actually write separate queries based on what we need, and we only return the data that we need. So in that case, you don't put the data on the wire that you don't need to put on the wire. The other thing too, back to the schemaless point, is if you do have different order types, like in my example, there's an indexed field that makes it really easy to only return the order type that you want to see and not the order types that you don't want to see, even if they contain the same attributes. So, if that makes sense.
Yep, thank you. And
sorry.
One another question I have is you were walking through us the comparison metrics that you have done across different components, right? AWS search or something like that. And I was just curious to know if you also considered Elasticsearch and its capabilities when doing that. What was your thoughts on that?
Yeah, we absolutely did consider Elasticsearch, and many of us, including myself, had experience using Elasticsearch in the past. If you've had experience operating Elasticsearch, you know that it's difficult to provision. You have to maintain it, you have to get all the infrastructure stood up, you have to sync the data across. And so all of those things were things that we were trying to avoid, because honestly, from an operational perspective, when I was running Atlas Search in a previous life, sorry, not Atlas Search, Elasticsearch in a previous life, most of the incidents we had with that platform were related to those things, were related to the infrastructure, related to the data sync, and we wanted to avoid having those problems if we could.
Thank you.
And so that's why we didn't even bring it in.
Thank you.
I have another question over here.
A quick question on the nature of the data. Was this like MLS kind of data in RETS format, or how was the data source of the data, or the starting point?
Okay, so we have a lot of different data. We have MLS data in about every format that you can possibly think of. Now, again, we use Atlas in many different places. For our listing data that I represented in the slides, that is primarily our own normalized schema. So we take data in from hundreds of different MLSs and other sources, and then we normalize it into a schema that we use. hopefully that answers your question.
Hi, Brian. My question is that you mentioned that you are getting the MLS data and storing it in MongoDB. Is it your primary source of data, storing it in MongoDB? And also, MLS data contains, like, every listing has a lot of attributes, a lot of data. Do you store it in like one collection or like one document? And if you do store it in multiple documents, how do you manage like creating an index from different documents? And another question I have is, how do you use vector? Like, what is the usage of vector for your use case?
Okay, so starting off, we do store the MLS data in a single document today. It is not the only place that we store MLS data. So MLS data goes through an entire processing pipeline, and it ends up being stored in Mongo for our listing and property APIs. So it's primarily the data source for the API. Now, vector, we're not using it in production yet. We are attempting to look at some use cases. So some of the use cases that we've been thinking about is, back to that search experience. That's a little clunky, right? You have to select a bunch of different attributes, and when you do that, even if you draw like a custom geoshape, you end up with a lot more properties than you probably want to see. You're going to get a list of a couple of hundred properties, and you're probably going to open 5. So how do I build something that allows me to search properties in a way that I don't get 250 and have to filter them manually down to 5, and I get maybe 15 or 20 that I filter down to 5? And so that's what we're looking at doing, is how do I use vector, whether it be natural language querying with advanced attributes, whether it be building embeddings on the photos that are associated to listings so that I can have more attributes than what are typically defined. And I think you also asked another question, which I didn't answer, and that was, do we store all of those attributes? Yes, we have thousands of attributes. Do we store them all? No, but we store a lot of them. If you know a little bit about MLSs, you also know that no two MLSs are the same, and they name things different, and so you end up with just a ton of stuff. So we try to normalize that and bring it down from thousands into a reasonable amount.
Hi, Brian. So beyond MongoDB being used, you should be having some legacy databases as well, and also the relational databases. How are we looking at it? Are we planning to move those data sources into MongoDB, or you want to keep them as such?
For the most part, I would put it this way. If we're building something new, we're going to consider using Mongo, depending upon the use case. We are not proactively looking at taking functional systems and moving them into Mongo, unless we're planning to modernize that system.
Okay. And with respect to the latest, sorry. And with respect to the latest data analytics and AI deep learning stuff, which one do you find more advantageous? Is it MongoDB or the SQL databases? Relational.
So that's a good question. I don't know that I've actually considered using a SQL database related to AI and machine learning. The main reason is that most of the use cases that I have right now, the data is in Mongo. And given the fact that the vector DB, the search functionality, it's all there, and I can store the vectors next to the primary data, I don't know why I would look at using it with a relational database, but there may be a use case where I do. I don't know. Just haven't gotten there yet.
We have time for one more question.
Sorry.
Hi, Brent. So you have a dedicated search nodes. In which cluster we are currently maintaining it? I heard that the MongoDB is not supporting the Azure such dedicated nodes.
Yeah, I don't know that answer because I don't use Azure with MongoDB, so I'm not sure about that, but the dedicated search nodes are relatively new. We're using it on 2 of our smaller clusters right now, and what was the other part of your question? I'm sorry.
Same. I just want to understand your dedicated search node is on Azure or some other AWS or GSP?
Yeah, sorry, that's it. Yeah, it's on AWS.
Oh, thank you.